Hi, so here's the video lecture about the paired t-test, which is also sometimes called the dependent samples t-test. So this t-test is different from the last t-test we did, the two-sample t-test, which is also called the independent samples t-test. Just like we did before, you don't have to worry about Z versus T. We'll always use the T. So the first thing we need to do is talk about what does it mean to be a paired t-test. How's that different from the independent samples t-test? Well, what you're looking for is whether the data is paired in some way. For paired data or dependent data, the observations are, not surprisingly, paired in some way. A lot of times it comes from before and after measures, repeated measures on the same item, or any other way in which we can match two pairs together. For independent samples, the observations are not paired in any way. You don't even have to have the same number of observations in the two samples, just like we saw with one of the examples before, where we had people drop out of one of the groups. But paired data really boils down to one sample that has multiple measures compared to the independent samples, which are really two different samples. So take a look at these four examples and see if you can figure out whether they're paired or independent samples. Write down your answers and pause the video, and we'll see how many you got right. Alright, so the first one, on average, do husbands earn more money than their wives? That one, we have husbands compared to their wives. So you would have to have those husband-wife pairs together. You couldn't separate those in any way. So that one is going to be paired data. Okay, so you wouldn't want to compare, one husband to somebody else's wife. You'd want to compare husbands to their wives. The second example, at Bank of America, do men earn more money on average than women? That was going to be independent samples because we really have two different samples of men and women. So to compare the first two examples, on both of them, we really are trying to get at men versus women. But the second one is not comparing the two pairs or several pairs to each other. And this is actually one way that in research they can control for a factor that might be an extraneous factor or a confounding factor. So if you compare, do husbands earn more money than their wives, you kind of maybe eliminate the effect of family background or something similar to that. I realize that that's not a perfect example, but pairing data is one way that they control for confounding factors. Anyway, so example 3, do houses with garages sell for more on average than houses without garages? Well, those are two different samples. We really don't have any pairing going on there. So those would be independent samples. Example 4, this is going to be paired. We really have the same students with repeated measures on them. So we have a before and after scenario here. All right, so here's another example. You've probably seen commercials like this where you have somebody taking a shopping list to different stores and comparing the cost. And they might want to know, is store 1 more expensive on average than store 2? Well, the way we conduct this test is we compare the differences. And so what they do is they compute each of the differences. Store 1 minus store 2. So here you've got $1.89 minus $1.99, which means you get a difference of negative 10 cents. It means that store 2 was 10 cents more expensive than store 1. And we do that for all of these. Okay? And it doesn't matter which way you do the subtraction as long as you're consistent throughout the problem. Notice here that if the price at store 1 is bigger than the price at store 2, like with item B, the difference will be greater than 0. Otherwise, if store 2 is more expensive and we do store 1 minus store 2, we'll get a negative difference. If they are the same, we'll get a difference of 0. And this matters because what we're wanting to do now is compare, look at the mean difference. Okay? And what we actually do with the pair t-test is really just a one sample t-test on those differences. So the mean of the differences, we call that x bar d. So going back and looking here, if we take the mean of all of these differences, that's x bar with a subscript of d, just x bar d. And we're using that as a point estimate for mu d, the population mean of the differences. So we did our calculations as store 1 minus store 2. If we do a hypothesis test and we can conclude that the population mean of the differences, mu d, is greater than 0, then we'll know that store 1 is more expensive on average. Okay? So we're always wanting to compare to 0, so the hypothesized value for a paired t-test is always going to be 0. So in our example, we wanted to know if we could conclude that store 1 was more expensive than store 2. So the null hypothesis is that there is no difference between the prices on average, which would mean that mu d is equal 0. Compare that to store 1 being more expensive on average, which would be mu d greater than 0. Keep in mind that that's only because we did store 1 minus store 2. If we had done it the other way, if we'd done store 2 minus store 1, then the inequality here would go the other direction. It would be less than. So from StatCrunch, we get the test statistic is 1.5046 and the p-value is 0.0854. And we fail to reject H0. Well, as always, we're rejecting H0 if p-value is less than alpha. So we're failing to reject H0, and we say that there is not sufficient evidence to conclude that store 1 is more expensive on average. Okay, and we never want to lose sight of the fact that we're inferring to the population. We know what the sample looks like. We found that the mean difference was, what did we find it was? Well, I don't guess we stated it, but what we want to know about is the population. So we want to know if, for all of the items in the store, store 1 is more expensive than store 2. Here's what the StatCrunch output looks like. And actually there is the sample difference. So store 1 minus store 2 has a difference of about 19 cents. So that means that according to our sample, store 1 was about 19 cents more expensive than store 2. The notation here in StatCrunch, mu1 minus mu2, I've never seen that notation before. The hypotheses in the book are in terms of mu-d, and that's more standard notation. It's not technically incorrect to use mu1 minus mu2, but some of the other calculations behind the scenes as part of the standard deviation and whatever is a little bit different. Alright, so here's another example. We have a car company with a new gasoline additive, and they claim that it improves gas mileage. So we're going to take 10 cars and we're going to measure the gas mileage with the additive and without the additive. Okay, so we have repeated measures here. So this here represents the same car. So the first car they tested had 28 miles per gallon without the additive and 31 miles per gallon with the additive, for example. So that's why this would be a paired t-test. So we have 10 different cars, so we have 10 different cars being tested, and we have repeated measures on those cars, which makes it a paired t-test. So we can pick whichever way we want to do the subtraction, without the additive minus with the additive, or vice versa. What I usually do is I'll always choose the difference to be the biggest minus the smallest, at least according to the hypothesis. That way the alternative hypothesis will always be greater than 0. I do that just to keep it simple. You don't have to do it that way. But so according to this, the additive is hypothesized to be higher. So we'll do D calculated as with minus without. So here's our output. We do with minus without. The sample difference is 1.6, which means that on average, with the additive, people would get 1.6 more miles per gallon. And then there's our test statistic and p-value. Reject H0 if p-value is less than 0.05. This p-value 0.0147 is less than 0.05, so we would reject H0 and say that there is sufficient evidence that gas mileage is higher with the additive. Alright, so now just watch the tutorials on how to do this in StatCrunch and you'll be good to go.